Okay. Чувате ли ме, защото...
Yes, and you're being
Okay.
recorded, so you might as well switch.
Okay then. So what we're presenting is a snapshot sharing solution. The idea behind this is that the user can easily share a snapshot of the file system with a single click. I'm going to show how this works. This is just a visual demo. This UI is in no way connected to the backend or whatever. So first, I'm going to create a file system. I'm going to give a random name like file system or whatever. And there are a few options here. There's an additional option, which is My Storage++. This feature, which we're presenting, would work only with My Storage++, which actually allows for snapshots because it is a snapshot sharing solution. Makes sense. I'm just going to quickly go through the rest of the steps because they're not quite important. And the file system is initializing. Now I'm going to add some credentials magically. And so now that this is a ++ storage, I can convert it to a template. This is a setup before the one-click part. So I'm going to magically convert it to a template. Now it's a template. There's a clone button. Once a file system is a template, you can already clone it. At the moment I click this clone button, what's intended to happen is the current state of the file system is going to be snapshotted, and a new file system, a temporary one, is going to be created so that it can be shared with other users, and etc. I'm going to click clone. And what we saw here is actually a clone of file system, which has expiry time. And once it is created, it can be sent to a user, who can then initialize it with some credentials and play with the data for a limited time without actually touching the original files. That's basically the idea. And now I'm letting Asen do the rest of the work.
Okay, thanks, Lucy. Can you stop sharing?
Yep. If I can find the button, I'm just going to leave the meeting and join you. I hope so.
Okay, so this was so cool. Now we have to implement it. You see what you've done?
Yeah. Yeah, well, what I'm going to show is going the other way around in the whole formula. Sorry, wrong slide. So basically, this is the overall architecture in our flow sheet. And what we're trying to do is when you clone this file system, when you clone this template, you get all this part here at the bottom, the lucid service and the object store. You get a copy of those parts of them which you need. And then you get a second file system that has the same file metadata encrypted in the same way and the same objects encrypted in the same way in another bucket in S3. And the beauty of it is that the user who has the encryption key and has the control of where the data is and what the data is still gets to keep it without us even knowing how to decrypt the data. So we just clone all we have in its encrypted state and it's still usable. Of course, what I'm going to show is just a prototype of a hub or lucid service, which I'm starting, and I'm configuring it to start in a state where it clones the data from an already existing lucid hub, and then it patches and reconfigures the metadata so that it can work with a new bucket, and automatically copies the objects that it needs from the old bucket to the new one. Meaning, in this old bucket, I can have many more objects than just those needed by the snapshot or the current state of the file system. The new hub will copy only those that it needs. Okay, and now let's get to the demo and have fingers crossed that it will work. So what I have so far here in this ugly terminal, I have a lucid hub already running, and it services the so-called test clone file space, which I have mounted here. Test clone, and you can see that I have just some file. What I'm going to do is like file true. I'm going to create some other file. sorry, I made a mistake. I'm going to populate it with some data. So it's just going to be some random text file with data. Yeah. And now let's try and copy some images here. So you can see the other file, which is bigger. It's created now. There is nothing staged here. Now let's just copy some pictures. I have a bunch of those.
What's this OneDrive? What is that?
I don't know. Know thy enemy, you know. So here is this Filespace. Just for a second, let me run Pulsit sync. Sorry, wrong instance actually. Okay, so now I have everything synchronized with this code process. What I'm going to do for the sake of the demo, I'm going to stop it and use the metadata currently found on the Lucid Hub instance and copy it to create a new Lucid Hub instance. Actually, I haven't tried it with the started Hub instance. I just don't want to screw it up. So now let's just start. Let's just start. Well, what should I say? Lucid Hub fs some clone daemon to make sure that there is some already running Lucid Hub, because that's what the portal is going to do anyway. And now I'm going to reconfigure this some clone daemon. Here is the name of the Filespace, some clone. To clone the data of the original daemon. Before we do that, let's see what it looks like on the S3 side. Here is the original bucket of the original Filespace. We see a couple of objects there. And let's take a look at the metadata. Sorry. Oh, that. So we can take a look at the metadata of the original Filespace using the inspect tool, which M wrote. So this is our original Filespace, test clone, metadb, and here is a long list of values. What matters in all this list is that you can see in the beginning, this is the unique ID of the Filespace which we are using as template and which we are going to clone. So our new Filespace will have a separate ID, and let's take a look at what the metadata looks like for this some clone Filespace which we just created, and it's pretty close to almost nothing. So now we're gonna restart this some clone hub with a new magic parameter that says clone from path. Some clone. And clone from path, what it does, it takes the metadata in that path and it copies it to some clone, then it patches it to make sure that it has everything it needs to run correctly. And here is what it's saying. It's rewriting the keys. Now, there is some more magic. Yeah. And naturally, I seem to have a bug. The thing is that we don't need garbage collection, and in the clone Filespace, we only need what is live and what is current. So basically, that's why.
You mean we don't need to copy the garbage markers,
yes,
or we're not going to implement garbage collection at all?
We're not going to copy the garbage markers.
Okay.
And the deleted data.
And the deleted data. So that's why I'm removing the deleted keys. And guess what? I'm sure nobody called get iterator next. Yeah, bummer.
Well, we can rerun it.
Yeah, we can rerun it, but
I can pause. You want? Yeah. Let me pause.
Okay, so after managing glitch, let's redo this. So we're starting back up we are giving a new name of the clone file space, and we are cloning the data from here, and there we go. So we saw that all the metadata is rewritten, and all the logs that we saw above are the modifications or copyings of the objects from S3. So let's first have a look at what it looks like in S3. We see here a new bucket. It's named after the file space. Then there is some text cloned, and this is the ID of the new file space. So this is the ID of the old file space and the ID of the new file space. Now let's take a look at the metadata, which we saw before. Again, I'm going to have to stop the hub in order to be able to read the metadata because it's read and write protected. So here we go. This is what we saw before. As you can see, it's very little. What you need to remember is the ID of the file space, which is the same as the one that we saw here. So this is indeed a new file space. In all ways, it has a new name and it has a new ID. So let's bring the metadata now. And we can see that this new file space with the same ID now has everything that the old file space used to have without the deleted keys. And for reference, there is the original bucket, the original file system name, and the original ID of the file system. And now let's see that all the files are really there. So what I'm going to do is I'm going to start it up again. However, this time without clone from path, just being in the file space. And now I'm going to start an instance of a client. And then I'm going to link it. Yeah, almost. I call it some clone. And so here we go. You should be able to see the some clone here. And what? Okay, that's something that should not have happened.
But the metadata was there.
Yeah, the metadata was there. That's strange.
F5? No?
No, it's not working. It's quite strange.
Maybe some key is different. Just. I don't know.
No,
Try from the command prompt.
that's what I'm trying, and it's not even there. Wait. Let's make sure that. That's again. It's really again. So, okay. There is no point in wasting more time in this. It's failing for some reason.
But that's the basic idea.
Yeah, it just work.
So we can clone existing file spaces on the server side without compromising security, without us being able to look at the data, all 9 yards. So
Yeah.
that's the basic
And
idea.
you can give the different shared secret. That's
You
right.
can change the shared secret afterwards. Yeah.
So let me add to that, right? Emo and I put in some thought last week on how we can implement writable snapshots, because writable snapshots are in essence clone version of your file space, but without using a separate file space within the same file space, right?
Yeah.
And so we can actually do something along the same lines, just keeping it within the same file space. You can pick a snapshot and say clone, and the act of cloning that snapshot now creates a second live version of the file space.
Yeah.
That you can, temporarily use for whatever purposes and then discard whatever. And that's something we can also do, by the way, which is solves the same problem in a completely different way.
Actually, there is one more thing. I don't know, Rodino or Lucy suggested today, or Max maybe. We can also clone a subfolder in that way because we have control over which keys from the LMDB database we keep. So what we can do is we can clone a new file space that contains only the files from a subfolder of your current file space. It will have the same security in the beginning, only a subset of the files.
That's a bit trickier, but maybe possible.
No?
Okay.
So
All right.
I
Anything
have
else?
a
Yeah.
couple of questions.
Yes.
So in the beginning, you mentioned that the primary use case for this would be sharing like a copy of a file system with someone who can play with it and then throw it away. But I see this more valuable as actually a way to migrate your file space from one region to the other, or even one provider to the other.
Very good point. That's way more valuable than just for testing. And that's something you cannot do with what I suggested earlier, which was cloning a snapshot because you're within the same file space, i.e. within the same, provider bucket or whatever. So yes, that gives you migration. That's right. And I was going to say, to some extent, you can avoid the egress charges, but you can't. Because even if we do it on the server side, we'll get charged for egress. The difference is that we, Lucid Link, will get charged, so we get to absorb the, the cost. I don't know if that's really that appealing from the business side, but yeah.
We can move it to the client. Like, we can do it in Lucid app.
Then you'll be able to also re-encrypt it.
Yeah, exactly. That was our approach we discussed, but we stopped at that as a better solution for now.
Anything else?
Nope.
All right. Thank you, guys. Done.